Hello guys, welcome to MoBileMaThS with Gamchurai. Today we want to look at logarithms. So I'm going to introduce, let's say we have got a number 1. We've got a number 1. If we want to write it in terms of power, its power, we'll have it as 10 to the power of 0, remember from indices. Then if we want to write it as logarithms, in terms of logarithms, it's log 1 is equal to 0. Okay, so that's how we write our logs in terms of numbers. Now let's continue this. Let's say we now have 10, so it's now 10 to the power of 1. Then in terms of logarithms, that's log 10 and it's equal to 1. Going down, we can go as far as let's take 1000. 1000 is now 10 to the power of the zeros. The power is the number of the zeros that we have, so this becomes 10 to the power of 3, and it's gonna be log of 1000 and it's equal to 3. It's like we are taking the power. Okay, let's have 10,000. So we have 4 zeros, so that's 10 to the power of 4. It becomes log of 10,000. It's equal to a 4. Okay, it's equal to a 4. So that's how we do our numbers in relation to our powers. So you can even try, I left out here, I left out 100. You can even try that 100. You can also try 100,000. Just take note of the zeros there. That's how you do the number power logarithm. Okay, let's continue. Now, looking at logarithms, it shows that they can be in base other than 10. We have looked at a base of 10, but we can also have examples of logarithms with bases other than 10. For example, I can have 32 like that. This is equal to 2 to the power of 5. Remember the importance of the power there. And if we want to write it in terms of logarithms, this is log 2, log 32 base 2, sorry, this is the base. So it's log 32 base 2 is equal to 5, like that. So in other words, the term logarithm is another word that can be used as power. Okay, and what it means is the logarithm of a number. What it means is that the logarithm of a number is the power to which 10 is raised to give that number. That's what it means in other words. Okay, let me show you what I mean. What I mean is this. Let's say I've got log 1 base 10. This is equal to 0. Okay, and let's have another example. Log 10 base 10. This now is equal to a 1. Okay, so what we mean, remember we say the logarithm of a number is the power to which 10 is raised to give that number. Okay, so that's what we are doing, like from the introduction where I was showing that if we have a number 10 to the 1, it's 10 to the power of 0, so its logarithms, I said if we have 1 like this, it means it's a number that is 10 to the power of 0. Okay, so this power there is the one that it is getting here. Okay, I hope I have explained myself. The same goes to this one. It's like we now have a 10 from those introduction that I gave, where I was saying this is a number. So this is a number, this is the number, and this is the power. This 0 here is the power. So this becomes 10 to the power of 1. That's why you see log 10 base 10 is equal to 1. Okay, so it's like we are raising our number to it's like the logarithm of a number is the power to which 10 is raised to give that number. That's what basically we are saying here. Okay, so maybe we can continue. What happens is this: when we have logarithms, let's say we have got a log of any number between 1 and 10. The number or the value of that log will get any number that is between 0 and 10 and 1. We'll get 0.11, 0.2, 0. So our numbers will be between 0 and 1, like that. I'll show you in examples. Before we do examples, let me introduce some laws that we have in logarithms. Okay, we have got 3 laws. The first law is this: we have got log m by n is equal to is the same as log m plus log n. Okay, I'll leave the gap. Then we have got another one. So this is one. Another one is log m over n is equal to log m minus log n. Okay, I'll leave a gap. Then the last one is log m to the power of p is equal to p log m. Okay, so I was leaving a gap because I wanted to relate these logarithms with our laws of indices. Like the first one is the same as x to the power of a times x to the power of b. We said whenever we are multiplying numbers with the same base, we add their power, so it becomes x to the power of a plus b. That's what we are taking. That's where we are taking it from. Then the next one is x to the power of a divided by, because we have got log m over n, that's division, so divided by x to the power of b is the same as x to the power of a minus b. That's how we are getting that. Then the last one, we also have something similar where we have got x to the power of a raised to the power of b. I'll show you how we use this one. Is x to the power of a times b, which is equal to x ab. I'll show you this one later on, though it's not really directed to this one that we are showing you. Okay, let's have an example. Okay, so I've got this question here where we are given a log and they want us to find certain logarithms without using a calculator. Okay, so that's the importance of this video. So what happens is this: for example, the first one where we want to find log of 37, we are given 3.7 there. What happens is this: we can rewrite this as log 3.7 times log 10. Okay, this is a times here. Okay, so when I have something like this, it means it can become as in terms of their powers, I have 10 to the power of 0.5682 times 10 to the power of 1. Okay, like this. Okay, so that's what I have. Then because of the law of the law that I was showing you earlier on, the same base, it means we add these powers there. So adding the powers now, it means our log 37 becomes 1.5682. Okay, that's the value. Then the second example, we want to find log of 0.037 there. Let's do that. Log of 0.037. 0.037. Okay, so what we do again, we rewrite it. We can rewrite it as a log of 10. Sorry, let me write the logs I was doing for the previous question. We can have it as log 3.7 times 0.01, like that. Okay, now we have separated and included our 3.7 that we are given there. Now let's write this in terms of their powers. It becomes 10 to the power of 0.5682 times 10 to the power of minus 2, like that. Okay, now we said when we are multiplying, we add the powers. Adding the powers because of the same base, 10, 10, we can now have minus, we get minus 2.5682. Okay,